Hello, Algebra 1 students. Today we're going to be going over the Unit 1 bookwork. So this is, you're going to need your textbook, looks like this. And we're going to go over, basically in your packet, you'll see that there's a section that's basically independent work, and it's just bookwork. But we're going to be going over quite a few of the problems. Some of the problems I'll be asking you to do on your own, but I'll basically just tell you which those are, and you can pause the video and work on those. I'm only going to ask you to do ones that are similar to ones that I've already shown you how to do, just usually with just different numbers switched out. But if you write everything that I write and just kind of follow along, I'm sure you'll do well. So let's go ahead and look at the first page of bookwork. And I'm going to share my screen here. And for all these problems, I want you to write down the problem to start. So this first set of problems is on page 33 through 35. Go ahead and turn there in your textbook. And you should see on page 33, and we're going to just do the numbered problems here. So starting with number 2, and you should always write down the problem before you start. Unless it's like a word problem, then you don't have to write down the problem for those. But for word problems, I do want you to answer in a complete sentence. But as far as just ones that are computational, like number 2 here, write down the problem always to start. So let's take a look for number 2. It's -2 plus -1. So you have -2 plus a -1, so that's -3. Okay. Basically, you could think of it like money. If you owe me $2 and then you owe your friend $1, well, then you would say you owe $3. Okay. So see if you could do number 4 on your own. It's very similar to number 2 here. Number 6, this is essentially you have 1.5, but you owe 8.5. Okay. So essentially you have a positive 1.5 and a negative 8.5. You obviously have more negatives here, so that's going to be negative, and that's going to be 7. Okay, so that's going to be -7. Think of it like money, right? If you have $1.50, but you owe $8.50, well, you could pay back the $1.50, but you'd still owe 7, right? You'd still owe $7. For number 8, this is our first word problem. It says, how is subtraction related to addition? So here I just kind of want you to explain in a sentence or two that when it comes to subtracting a number, that's the same as adding a negative. So for example, if I've got 8 minus 2, that's the same as saying 8 plus -2. So that's basically what I want you to explain there, that relationship, the fact that when you subtract a number, that's the same as adding the negative of that number. For number 10, I put a little check mark here because I want you to do that one on your own. It's just 2 plus 5. I'm pretty sure you can do it. For number 12, 4 plus -3. So 4 plus -3. That's the same as saying 4 minus 3, by the way. So if you have 4 positives and 3 negatives, that's going to give you +1. Okay. You have $4, but you owe 3. Well, you'd have 1 left over after you pay your debt. Okay. Number 14 here. This is kind of like you owe $6 but you have 9, right? Well, you'd be able to pay your debt and you'd still have 3 left over, right? So kind of with positives and negatives, if there's, you're adding and subtracting, whatever, basically if they're different signs, they cancel each other and you're left with whatever sign that you have more of. So in this case, you have more positives. So the answer is going to be positive. In this one, these are not different signs. These are the same sign, right? They're both negative. So they don't subtract each other. They actually combine together, right? This is like if you owe me 6 and you owe your friend 8, well, you would have a total debt. You'd owe 14, okay? For 18, 20, 22, and 24, go ahead and give those a try on your own. I'm pretty sure you could do them. I do want to emphasize that you should write the problem before you show your work and do the problem. Okay. You could pause the video and work on those 4. 26, negative 2.2 and negative 3.8. Again, they're both negative, so they kind of just add together, right? So that's going to be negative 6 equals negative 6. When it comes to adding or subtracting fractions, you need to have a common denominator. So that's the first thing we want to look at here. And I know we covered that in the guided practice, how to find a lowest common denominator. But for these two numbers, the lowest common denominator is actually going to be 15. So we're going to change both our denominators to have a denominator of 15. Okay. Negative, and this one's going to be negative here. Okay. I do want to also point out that when it comes to negatives on a fraction, you could put the negative on the numerator like this. That's the same as putting it in front of the fraction like that. And it's also the same as putting it in the denominator. So these all have the same value. You could put the negative on any part. Okay. Usually you'll see it either on the numerator or in front of the fraction. So when I put it up here on the numerator, for example, and then on the next step, I put it down in front of the fraction, these are the same. Okay, that's the same exact thing. Okay, so I'm going to change both my denominators to 15ths. So here it went from thirds. Well, how do I go to 15? Well, I multiply by 5. If I multiply the denominator by 5, you have to multiply the numerator similarly by 5. So that's going to be 10. 5 times 2 is 10. Here, to get to 15, we multiply the denominator by 3. And so you multiply the numerator also by 3, giving us 9/15. Okay, so we have negative 10/15 plus negative 9/15. Again, they're both negative, so they're going to go and add together. So that's negative 19/15. Okay, and again, you could put the negative on the numerator, which is usually what I do. But you could put the negative in front of the fraction. That's acceptable as well. Okay, 5 minus 15. So this is the same as saying positive 5, negative 15. So you have $5 and you owe 15, right? So here, if you combine those together, you'd have more negatives, right? So it'd be negative 10, right? If you have 5, but you owe 15, well, you could pay the 5, but you'd still owe 10 at the end. For this one, they're both negative. So they're actually going to add together. So that's negative 26, right? You owe 19, and then you owe 7 more. So you owe 26 in total. Number 34 here, this one, we've seen some of these before in the guided practice where you see a negative in front of another negative like that. That turns it into a plus. So this is the same as making negative 29 plus 11. So let's go ahead and rewrite it like that. And then you owe me 29, but you have 11. Well, if you paid me that 11, you would still owe me 18. Okay, hopefully that makes sense. Here they're different signs, they cancel each other. Here, you have 8.5, but you owe 7.6. So you can do it in 8.5 minus 7.6. By the way, and this will be positive because is it positive 0.9? It's positive because you have more positives. The negatives and positives cancel each other, but you have more positives, right? By the way, you're welcome to use a calculator pretty much throughout this entire course. So feel free to have a calculator on hand. I always do. And you can go ahead and use that whenever. Okay, 38. Here again, we see that negative, right? One negative after another on that 7.5. So that's going to make it a plus. So that's going to be negative 2.9 plus 7.5. So you have a negative 2.9 and now a positive 7.5. They're different signs here, so they do cancel each other. And will our answer should be positive or negative? What do you think? Well, hopefully you see that our answer should be positive because we have more positives here. So that's 4.6 for this one. Positive again because we have more positives. Okay, here we're subtracting fractions. And once again, whenever we're adding or subtracting fractions, we want to make sure they have the same denominator before we do anything else. So in this case, we could change both the denominators to eighths. The first fraction is already in eighths, so there's no need to change it. But the second fraction needs to change from fourths to eighths. So we're going to multiply by 2 on both the numerator and denominator to change it to a fraction with the denominator of 8. So that's going to become 6/8 in this case. You could always double check to make sure that this fraction is equal to that one by putting in the calculator, right? 3 divided by 4 should equal the same amount as 6 divided by 8. You could check that. They'll give you the same decimal, 0.75. Okay, so now we just subtract 1 minus 6, essentially, or in other words, positive 1 and negative 6 makes negative 5. The denominator, do not subtract those or add those or anything, just gets carried along. 42. This one is a word problem. So hopefully you have your book open to page 34. And just, this is question 42 here. So I'm going to read it out loud, so please follow along. It says, an eagle starts flying at an elevation of 42 feet. Elevation is the distance above sea level. The diagram below shows the elevation changes during the eagle's flight. Write an expression representing the eagle's flight. What is the elevation at the brook? Okay. So it starts at an elevation, in the words, it says starts at an elevation of 42. So starts at 42 feet, but then it goes up. You can see that in the diagram. It says up 144. So that means we're going to add 144 feet to our elevation. Then it says it went down 126. So it's going to be subtract 126. Okay, when it's going down in elevation, we're subtracting that. Then up 25, then down 65. Okay, and then we would just kind of go through this. So 42 plus 144 is 186. Then minus 126, that gives us 40. And then plus 25 gives us 65. And then minus 65 gives us 0. So at the end of it, he would have an elevation of 0. It would be at sea level, essentially. Okay, 43. This is very similar, it just doesn't have a picture. It says a stock's starting price per share is $51.41. So its starting price is $51.47 at the beginning of the week. During the week, the price changes by gaining $1.22. So gains $1.22. Then loses $3.47. So losing $3.47. Then losing $2.11. So again, subtraction, 211. Then losing another 98 cents. So losing another 0.98. Okay, I hope that makes sense where it says if it gains in value, we're going to add that. If it loses value, subtract that. Okay, you can go ahead and I would just put this in your calculator. 51.47 plus 1.22 minus 3.47 minus 2.11 minus 0.98 gives us a total. So at the end of the week, its value, the price per share, will be $46.13. Okay, hopefully you got the same answer. 52. All right, so this one is basically talking about golf. So here's what I want you to do. I just want you to go and just calculate the score. Okay, so you don't have to do all this. So when you look at that golf problem, number 52, you'll see there's a scoreboard on the right in that green scoreboard on page 35. And you see it says +2, -1, 0, -2. So we're just going to add those scores together. So +2 minus 1 plus 0. Well, that doesn't do anything, but go ahead and write it anyway. Then minus 2. So this will give the golfer a score of -1, which is actually a super good score. In golf, the lower your score, the better. So a score of -1 is very good. Okay, let's move on to the next section. So this section starts on pages 42 and 43 of the textbook. So go ahead and turn your textbook to page 42 and 43, and you should see those problems there. So we're going to start on problem number 8, and it says -8 times 12. Okay, so just to recap the rules for multiplying and dividing with positives, negatives, if it's a negative times another negative, this will always give you a positive. And same thing with dividing. A negative divided by a negative gives you a positive. But if they're different signs, like a negative times a positive, this always gives you a negative. So it's a lot simpler rules than the adding and subtracting, right? Here you just say, okay, there's a positive, negative, or two negatives or whatever, and you just go off that. So here we have a negative times a positive. Okay, well, if they're different signs, that's going to give us a negative answer. And then we just multiply. So 8 times 12 is 96. And so our answer will be -96. Okay, try number 9 on your own. Try number 10 on your own. So go ahead and do these on your own. All right. Let's go ahead and pause the video and do those on your own if you can. Now, number 11, it says 5 times 4.1. Okay. So when you're multiplying, you could use your calculator here, but this one's actually going to be 20.5. Okay, that's it. Okay, try number 12 on your own. Try 13 on your own. So I'm going to ask you to do that one and do this one on your own. 14. So here we're multiplying a whole number times a fraction. So it's 6 times -1/4. Okay. So again, it's a positive times a negative. So I know my answer is going to be negative. But how do I multiply a whole number times a fraction? Well, it's actually pretty easy. I'll show you. So what you do is you can think of the whole number as that number over 1. And we're multiplying by -1/4. When you're multiplying fractions, you can multiply just top times top, bottom times the bottom. So 6 times 1 is 6. 1 times 4 is 4. And it's a positive times a negative, so that's going to be a negative. We should always reduce our fractions if we can. So in this case, we can reduce by dividing both top and bottom by 2, giving us a -3 over 2. Or -3/2, in other words. Number 15, we've got -1/9 times -3/4. So here we have a negative times a negative, so we know our answer is going to be positive. Now, when we are multiplying fractions again, we always multiply top times top, bottom times the bottom. So 1 times 3 is 3. 9 times 4 is 36. We can reduce this because both the numerator and denominator are divisible by 3. So that's going to give us, divide by 3 on both top and bottom, 1/12. Again, it's positive because it was a negative times a negative. Why don't you go ahead and try number 16 on your own? We'll do number 17 together here. So this is -2/11 times -11/2. Okay. So we can multiply top times top, bottom times the bottom. And we know our answer is going to be positive because it's a negative times a negative. So that's 22/22. Well, that's just 1, right? Anything divided by itself is 1. 18. We haven't seen one like this before, but I'll go ahead and show you. It's -2/9. And then it has an exponent. It says to the power of 2. or in other words, negative 2/9 squared. So when you see something to the power of 2, a lot of times we'll just say squared. So negative 2/9 squared. That just means to the power of 2. Now, what does that mean, though? What does to the power of 2 mean? That means you multiply this thing times itself. So this is the same as asking what's negative 2/9 times itself. So that's times negative 2/9. Again, we can multiply the top times top, bottom times the bottom. So this is 4 over 81. Now, should this be positive or negative? What do you think? Well, hopefully you can see that this is a negative times a negative. Well, that should give you a positive. So positive here. 19. We have negative 1.2 squared. So that's the same as saying negative 1.2 times itself. So whenever you see that squared, that means that number times itself. So negative 1.2 times negative 1.2. So hopefully you'd see that this answer would be a positive, right? So what's 1.2 times itself? So that's 1.44. In this case, positive, because a negative times negative is positive. Okay. Number 30. Now we're working with division. So this first one says 48 divided by 3. Now, what you're going to see most of the time throughout the rest of your math career is you're going to see division written as a fraction. Okay, so you're not going to usually see this symbol where it's a dot, line, dot. For division, you usually won't see that. You'll see more often 48 over 3, but just know that that also means division. Okay, so 48 divided by 3 is 16, and you're done. Okay. 31. Negative 84 divided by 14. Now, it's the same rules where a positive times a negative was negative, right? Same rules with division. A negative divided by a positive, right? The different signs, this will come out to a negative answer. Okay, so if they're different signs, it comes out negative. Same rules with multiplying as it is with dividing. So 84 divided by 14, and that's 6. So negative 6 in our case. Similar, just like with multiplying, if you're dividing and they're both negative, so like in number 32, we have negative 39 divided by negative 13. So here, a negative divided by a negative, well, that's going to give you a positive. Okay, so in this case, positive 3. So it's the same as with multiplying. A negative times a negative is positive. Same thing with dividing. A negative divided by a negative is also positive. Okay. 33. Here you're doing division also. They just write it as a fraction. But just know that that still means division. Okay. So a fraction is just another way of writing division. Here we have a positive divided by a negative. So they're different signs once again. So that's going to be negative. In this case, negative 3. See if you can do number 34 on your own and try 35 on your own. Try 36 on your own. And for 37, you could just use the calculator and try that on your own. Okay? So go ahead and give those a try on your own. Finish the rest of those. Okay. Once you're done with that, we can move on to the next set of problems. So page 141 and 142. So go in your textbook and go to those pages, 141, 142. And we're going to start with problem number 15 here. So problem number 15, you can see find each part. So it says, what is 25% of 144? So 25% of 144. So hopefully you remember from when we covered this in the guided practice that to find a percentage of a number, the simplest way is just to change this percentage to a decimal. So in order to do that, you move the percentage over twice. So that's 0.25. Again, moving the decimal over, moving the percentage over twice and making it a decimal. That just means multiply by 144. So 0.25 times 144. So that's 36. Just like that. Okay. So for number 16, it's the same idea. Okay, so it's 63% of 150. So go ahead and try that on your own. Okay, should be just like this one. And you could use a calculator. Number 17. Number 17 is asking what's 12.5% of 104. So in this case, the percentage has a decimal in it. So do I move the percentage sign over twice, or should I move the decimal over twice? Well, in this case, you'd move the decimal over twice. Okay, so if there's a decimal in the percentage, you want to move the decimal over twice. So that's going to make 0.125 of, that means multiply, 104. So this will be 12.5% of 104. Let's go ahead and put that in a calculator. 0.125 times 104. 13. For number 18, it says what's 150% of 63. So here we want to definitely move that percentage over twice and multiply it together. So move that percentage over twice. That's going to make 1.50 times 63. And that'll give us our answer. So here it's greater than 100%. You see that? So our answer is actually going to be greater than 63 because 100% of 63 is 63. So 150% of 63 should be more. Let's see. 1.5 times 63. This gives us 94.5. Just like that. Okay. So again, whenever you're finding a percentage of a number, just change that percentage to a decimal and multiply that together. 19. Go ahead and try number 19 on your own. And number 20, we'll go ahead and do together. So this one asks, what's 1% of 1? Okay. So again, the 1%, we want to change that to a decimal. Don't forget, we move that percentage over twice. Always, always twice. So that's going to be 0.01 times 1. Okay. Well, anything times 1 is itself, so that's going to be 0.01. Okay. Hopefully that made sense. Number 21, we have a word problem here. It says, and you can follow along as I read aloud. A tennis racket normally costs $65. The tennis racket is on sale for 20% off. What is the sale price? So we want to do 20% off of the $65 normal sale. So first we want to find the discount. So we're going to do 20%, which is what we're taking off, of 65. So let's change that to a decimal. That's going to be 0.20 times 65. And what this will give you is how much we're taking off. So this will give you the 20% of 65, which is how much we're discounting. So 0.2 times 65. So that gives us 13. Now that's not our final answer. This is the discount. All right, so this is the amount we're going to take off. So the original price was 65, but we're going to take off whatever that discount was. So in this case, we're taking off $13. So that's going to be $52 is the final price of the tennis racket. It's a little bit trickier, but that's how it's done. 22. A beauty salon buys bottles of styling gel for $4.50 per bottle and marks up the price 40%. Okay. for what price does the salon sell each bottle? So they buy the bottle for $4.50, but they're going to mark it up by 40%. So first we need to find, I guess I should erase this. First, we're going to find 40% of $4.50. Okay, so change that to a decimal. That's 0.40 times 4.50. 1.8. So 1.8. But this tells you the markup. So you take the original price plus the markup, and that tells you what they're going to sell it for, right? Because if they're buying the bottle of styling gel for $4.50, they want to sell it for more than that. And so the markup tells you how much more they're selling it for. So let's go ahead and add the 4.5 there. So that means they're going to sell it for $6.30. Okay. Adding these together. 29. You deposit $1,200 in a savings account that earns simple interest at 3% per year. How much interest will you have earned after 3 years? So this one we haven't really covered before, but first we want to find the amount of interest they get every year. So in this case, it says you get 3% per year. So we want to find 3% of however much is in the account. So in our case, that's 1,200. So 3% of 1,200. Change that to a decimal, 0.03 times 1,200. Gives you $36. So that means that they earn, for interest, you'll earn $36 each year. Now it says it's in there for 3 years, so we multiply that by 3 for the 3 years. That means the amount of interest you'll earn after 3 years, multiplying this by 3, gives you $108. Okay. 30. You deposit $150 in a savings account that earns simple interest at a rate of 5.5% per year. So first we want to find 5.5% of the amount that you invest. So in our case, that's $150. So 5.5% of 150. First, let's change this percentage to a pure decimal by moving the decimal over 2 places. 0.055 times 150. This will tell you the amount of interest earned in 1 year. So the amount of interest gained in 1 year is $8.25. Now it says it's in there for 4 years. So we're going to go ahead and multiply that by 4. That gives you $33 for each. For after the 4 years, you'll earn $33 of interest. All right. 37. Geography. Water covers approximately 11,800 square miles of Florida, which is about 18% of Florida's area. What is the total area of Florida to the nearest 1,000 square miles? Okay, so this one's a little bit tricky, but it's basically saying that the amount of water coverage is 11,800. So we're going to say the water coverage over the total, which the total we don't know yet. That's what we're trying to find. But the water coverage it says is 18%. So that's 18% is 18 out of 100. Okay, this is a tricky one. But from here, what we do is cross multiply. So this we're going to cover in a later unit a lot more. So don't worry about it too much. But basically, when you have a proportion, which is when 2 fractions are set equal to each other, what you can do is cross multiply to solve for a missing part of that proportion. So in our case, that's going to be t times 18. So that's 18t. Again, cross multiplying. And then 11,800 times 100 is 118. And I'm going to put 1, 2, 3, 4 zeros. Now solve for t. To get t by itself, we're going to divide by 18. That'll give us the total area of Florida. I got 6, 5, 5. How many fives here? 5, 5. And we'll say 0.6. That's fine. Just rounding to the nearest tenth. 38. A student has $1,500 to deposit in a savings account. What is the lowest rate that would allow the student to earn 95% in simple interest in a year? Okay. All right, so the amount of interest they earn is $95. And we're going to put it as another proportion, kind of like the last one we just did. 95 out of 1,500. Since this is the total, that's going to be the 100%. And we need to figure out what percentage that is. So I'm going to put P for percent. Cross multiply. So this would be 1,500 times P equals 9,500. Divide both sides by 1,500 to get P by itself. That gives you that P equals 6.33. So that's C here in our problem. So 6.33 is the percentage. Okay, which is C. 148. So 148, we could see here, this is talking, if you turn to that page and look at page number 7 here, it says tell whether each percent change is an increase or a decrease. Then find the percent change, round to the nearest percent. So to find percent change, we haven't covered that yet, but basically when you have those two numbers, you're finding the percent change. What you do is you take the bigger one and you subtract the smaller one and you divide by whichever one was the original. Okay, this will give you your percent change. Okay, now it'll make sense as we work through some of the examples, but let's take a look at number 7. It says the original amount, I'll put OA for original amount. The original amount was 12. And the new amount, we'll put NA, is in this case 18. Okay. So if we originally had 12 and then we went to 18, would that be an increase or a decrease? So if we originally had 12 and now we have 18, that would be an increase, right? So we're going to put increase here. Okay. Now we're going to use this formula to find our percent change. So you take whichever one's bigger, in this case 18, you subtract whichever one's smaller, in this case 12, and then you divide by whichever one's the original. Well, that's 12 in our case. So 18 minus 12, that's 6, divided by 12. This gives us 0.5. If we want to change that decimal to a percentage, we move the decimal 2 times to the right. That's 50%. Okay. Let's try number 8. So the original amount for number 8 is 9. The new amount is 6. And since we originally had 9, but now we have 6, this was a decrease. So we're going to put decrease. Now, to figure out the percent change, we take the bigger one minus the smaller one, divide by the original one. So that's 3 out of 9. If you divide that, that's point. You should see 0.3 repeating on your calculator. If you change that to a decimal, but if you change it to a percent, we move the decimal over twice. So that's going to be 33.33%. Number 9. So all of these are basically the same. You're just going to follow this formula, the bigger one minus the smaller one divided by the original. Okay. So for number 9, we'll do one more example. The original amount is 15. The new amount is 14. So we started with 15, but now we only have 14. So this was, again, a decrease. And we're going to go ahead and use that percent change formula. So the bigger one minus the smaller one divided by the original. So in this case, the original is 15. 15 minus 14 is 1. So we do 1 over 15. Use our calculator to figure out what that decimal is. 1 divided by 15. So this gives you 0.0667, we'll say. Move the decimal over twice to change that to a percentage, and that's 6.67%. Okay. I want you to try the rest of these on your own. So try 10, 11, 12, 13, 14, 15. Try those on your own. Okay. 16 and 17, and this is the same sort of problem. They are just in words. They're just word problems. So let's go ahead and take a look at number 16. It says an employee was hired at a wage of $8 per hour. After a raise, the employee earns $8.75 per hour. What was the percent increase? So the original amount was $8. The new amount is $8.75, so 8.75. Now to figure out our percent change, we take the bigger one minus the smaller one and divide by the original one. So this gives us 0.75 divided by 8. 0.75 divided by 8. And that gives us 0.09375. Now to change that decimal to a percentage, we move the decimal twice to the right. So that's going to be 9.375%. Number 17. On June 1st, 2007, there were about 18.75 hours of daylight in Anchorage, Alaska. On November 1st, 2007, there's about 8.5 hours of daylight. What was the percent decrease? So the original amount of sunlight was 18.75 hours. So 18.75. The new amount has 8.5 hours. Now to figure out the percent change, we go and take the larger one minus the smaller one divided by the original. Okay, so this gives you 10.25 over 18.75. which gives you 0.5467, we'll say. I know it's like 6 is repeated, but if you round there. To change that to a percentage, you move the decimal over twice. So that's 54.67%. Okay. Once you're done with that, next is the performance task. I've already made a video about this performance task. So you could go ahead and give it a try on your own, give it a read. But when you're ready, you should just watch the video that where I explained that. Okay. All right. Well, with that, let me stop presenting. And I hope that made sense. Hope you're able to do the ones that I asked you to do on your own. But if you still need help, if it's not making sense or whatever, you could always email me. My email is ttrigg@ofy.org. All right. Well, with that, I'll see you guys next time. Take care.